Hi, I'm Jonathan Lance.
And I'm Dylan Sanchez.
We're two members of the team behind the Stop Here automatic pedestrian warning device. We're students in the Engineering 1222 Section 1 class in the fall 2025 quarter at Louisiana Tech University. We were inspired to create the Stop Here from seeing our fellow students trying to cross busy Tech Drive on foot when warning signals had not been activated at the crosswalks.
Our device plays a warning tone when a pedestrian and a car are detected at the crosswalk. Here's a short video on how this works.
Watch it!
Hello, my name is Riley Bryan. I'm the third member of Stop Here. Our system utilizes two sensors to detect for pedestrians and cars on the roadway. The first sensor our system utilizes is the IR light detector. It works by emitting a beam of IR light that could potentially reflect off of pedestrians about to enter the roadway. If the receiver sees the light, then a ping sensor begins scanning the roadway. Once the ultrasonic sensor is activated by the IR sensor, a pulse of ultrasonic sound is emitted down the roadway. The sound will bounce off any objects in the road back to the ping sensor. Utilizing the speed of sound, we can determine their distance down the road from the sensor. Objects only in a certain range that we define in our code will trigger a piezo speaker.
Our device is currently powered by a battery pack. Ideally, we would have a power source that would hook onto an existing power supply, such as a light pole at an intersection. But we've demonstrated that our device can be battery powered as well. The computing is done by this Arduino chip, and the wires from the Arduino run over to this breadboard, which has wires connecting to our speakers, a piezo speaker here and another speaker here, and to our sensors, the infrared light and sensor here, and the ping sensor located there. Our device uses aspects of three disciplines of engineering. First, our device used mechanical engineering principles to understand how the component parts are developed and how they come together in our device. Second, our device used aspects of electrical engineering to understand how the code interacts with the parts of this device. Particularly, we had to account for both timers on the Arduino chip and use both of those timers to successfully complete our device. Third, our device uses aspects of civil engineering, especially understanding how civil engineering design occurs. Because our device is designed to be placed around real people on real streets, we had to take into account how people might interact with our device. By using aspects from three disciplines of engineering, we were able to build this device to ensure that the car you don't see isn't the car you don't hear.